All right, so hopefully everyone can see our course page right now. So besides the YouTube videos, there's shorter videos that are actually on the course page that were there before all of this started, right? So a nice short video kind of going through 6.1, 6.2, and 6.4, which is the main part of chapter 6. Then another short video on 6.3 and 6.5, which is basically walking through how to do that Excel, which is what we did last class. So I also have the lecture loaded on the YouTube channel. So the videos on the course page are much shorter videos. They're 15 minutes or less, while the ones on the YouTube channel are the full lecture, right? So these are, if you don't want to sit through the full lecture again, but you just want a quick review, then these videos are really good, right? And so we have already on here a chapter 7 confidence interval, which basically goes through and talks about the concepts. I don't really do a lot of calculations on those. I just talk about the theory. So that's why it's a short video. And then I have a little video here to use technology to solve confidence intervals. So remember, don't forget about these videos as well as the ones on the YouTube. My stats class yesterday had a lot of questions about project 2. So if I go over here to coursework, and this weekend I will upload the requirements for people that want to present. I do what I wanted to do. Coursework. Oh, and don't forget about these things, right? So here is the handwritten lecture notes for chapter 6, chapter 7 and 8, and chapter 10. So that's all handwritten out. That should follow the lecture videos fairly well. If we go to coursework here. Slow. You have everything to be able to complete homework 3. So you can see homework 3 is through the 4. We've covered everything for homework 3. Homework 3 is just check. So you can either do the coursework or you can do the Pearson. A lot of discussion about which one is better. Pearson, well, if you're not comfortable with Pearson, the Pearson homework's a good one to practice before you take the test, because at least you'll know how to see how Pearson works. But which one's better to prepare for the test? They're basically the exact same thing in this case. So if we go here to project 2, and I change this to view as a student. So project 2, again, this is the optional one if you want to throw out one of your lower grades, right? So if you use your previous project, if you use project 1, then you don't have to worry about anything from part 1, right? Part 1's only if you're starting completely over, which I don't think any of you will be. Question 2 is again saying to write 3 to 4 pages. And then in your paper, these are the topics you have to cover, right? But it's really not that much, because how is the data collected? You answer that in the first project. Outliers, you answer that in the first project. You now have to build the QQ plot, which is what we talked about last class. If you're doing a proportion type problem, then make sure you talk about the requirements on page 374, because the QQ plot only works if you're doing averages. So if you're comparing the averages of stuff, right, then you can do a QQ plot. If you're doing something that you're looking at percentages or proportions of something, then you're not even actually going to do a QQ plot. You just have to verify the requirements that are on page 374, which is kind of what we're going to get into today. Find your sample statistics. You already did that in project 1. Then you're going to conduct a hypothesis, which we'll learn in chapter 8. We'll talk about types of error in chapter 8. And then you're going to build a class, is what we're starting. So in reality, to project 2, that's all the new stuff. And part of it is, most of it's already in your previous paper. So there's not a lot to it. Then I also had another student say, well, if I don't want to do the paper, like I don't want to replace a test grade, but I want to present, can I still do that? Yes, right? So, I mean, you have to do project 2 to present, but if you don't want to write the paper and submit it for grading because you don't want to just do all that extra work, but you at least want to go through and do some of project 2 so you can present versus taking the final, then that also is an option. So a lot of options here. You just got to decide what you want to do. If you want to stick to doing the final on Pearson, then you don't have to worry about any of this. If you don't want to take the final and you want to kind of continue to work on your projects, then this is an option for you. Any questions on that, the homework or the projects?
The test questions on Pearson, do you know how long it is?
The what? The test on Pearson? I haven't written the test yet.
Oh, okay.
Yeah, well, the test will be over chapter 6, 7. I don't know if about 8 yet. So I gotta get it written and see. It should be easily done within 90 minutes, just like if you're in the classroom. But I'm not gonna put a time limit. The time limit's gonna be, I will give it during a specific day, and you have to complete it within that day. And you'll have to also complete it in one setting. So don't start the test and think you can save and come back to it later. Once you start it, you must complete it.
For the Pearson homework, do you have to use like any codes to put in, kind of like how we do for Excel, kind of like to do
No.
like, okay.
No, they do have some technology. If you want to use StatCrunch, you can. If you want to do it by hand, you can. If you want to do it by Excel, it doesn't make you solve it using technology. If you want to use technology, you can. You don't have to. No, project 2 replace, if you do the paper project 2, it will replace either your lowest test score or replace project 1 if your project 1 grade is low. So project 2 is something you can do, is optional as a grade replacement. The final grade will be based off either you taking the final on Pearson or presenting your statistical findings to the class via Zoom. Now, that's your choice which one you want to do. So don't get the two confused. Project 2 paper replaces a test grade. Project presentation via Zoom is your final. If you don't want to present, then you'll take your final on Pearson. Any other questions?
You present
before we start today?
and you do your final. Do you take the highest grade or?
Yes.
Okay.
Let me do a quick check to see who apps. Oh. Okay. All right, so I don't mind search. I've heard him. It'd be good if our attendance in the Zoom applications, your attendance is by your last name, but the people in Zoom go by your first. For Pearson, just round based on whatever their rules are. If Pearson marks something wrong and it was just because of a rounding error, just message me, just send me, you hit on email my instructor in Pearson and say, hey, I got this question right. Then I just change your grade. That's all. That's easy, an easy fix. So I don't see James. Okay, thank you, Taylor. So I'll just mark him as present. For a deck, so I know he's here. DJ. Looking for my ones that are usually absent. This seems to be the easiest, quick way to do it. Brianna said she's going to be late. So 23, 24, 25, 26. '27. All right, close enough. All righty. So today we finally get into, after all these weeks, we get into some statistical analysis. So our first thing we're going to discuss as soon as I get this sharing right. Stop share. Share screen, whiteboard. Okay. There we go. Like I said, this video, we're going to start off talking about the theory a little bit, and then we will get into how to solve some of these. So probably today we'll talk theory, and we'll go and do a proportion. And then next class, we'll do the mean and the standard deviation. So the key to confidence intervals is understanding what a confidence interval is, but at the same time, knowing your symbols, right? Because these confidence interval formulas can be a little tricky. So let's first start talking about what is a confidence interval. So if I draw my lovely bell curve, no, I don't like yellow. Can't see yellow good. Clear. Draw. Start on my bell curve. Right? And in the middle of my bell curve is the mean, right? Or, yeah, we'll stick with the mean for now. We'll start with just the mean. So, and if I stick specifically to a standard normal, then I know I'm centered at 0, and I have a standard deviation of 1, right? And on my line here, my axes, this is my events. Right? And my events can be X's, what I'm looking for. It can be my mean. It can also be a proportion. So these, that's an ugly P, that's supposed to be a P for proportion. So my events are along this axis. So these are events if I'm down here. Any number down here is an event. Now, the question is it the event I'm looking for or not? That's what we're going to get into. But if I'm on this line, that is an event. If I am inside of here, this is a percentage or a probability, right? It is the probability that I am at that event, and depending which way I'm colored, more or less. So inside here is a percentage. And if I go from here all the way through here, and I color everything in, that is 100%. Right? That means I've covered everything. And in chapter 6, what we were doing is we were picking an X, drawing our line, and then coloring to find part of it, right? So that's what basically chapter 6 was doing for us. So we can't forget that because it is a key concept to all of this. Now, what we're going to do instead with confidence intervals is we're going to pick a percentage. And a common confidence interval that typically people do is a 95%. Oops. Where's that race? Come on, race. Typically a 95% confidence interval. Well, if I do that, I need, and it's called an interval. So that means I am going to have a left limit and I am going to have a right limit. So, and between my limits is my confidence interval percentage. So my confidence interval percentage is between these two limits. So we're kind of working backwards, right? So we know how much we've colored. We have colored 95% of the curve. And it is a between problem. So just like we were doing in chapter 6, if we're a between problem, then that means I had to find two different z-scores. So I have to find a z-score down here, and I have to find a z-score up here. And the reason I know this z-score to the left is negative is because it's less than 0. And I know this z-score to the right is positive because it's greater than 0. So I have to find these two z-scores. And I'm going to find them based off the fact I have a confidence interval percentage. Well, if I have 95% confidence, 90% of the graph colored in between the lines, how much of the graph is uncolored? So how much?
5%.
5%. So if 95% is colored, 5% no color. Right? However,
Yeah.
I have two parts that are not colored.
Mm-hmm.
And a normal bell curve is symmetric. So how much is in this lower tail? 2.5%.
2.5.
My right point. There we go. And then that means this is 2.5%. And if I add 2.5% plus 95 plus 5% plus 2.5%, I get my total of 100%. So if I know this lower tail is 2.5%, how do I find this z-score?
You look at the table?
You look at the table, right? So if I go to my table, I need to find what?
Negative 2.5.
Yeah, I got. Now remember the pinch, and it's not a z-score. This is a percentage. So I am looking for in the table the value 0.0025. That's what I'm looking for inside the table.
Negative 2.8.
Wouldn't it be 0.025, not 0.0025?
Oh yes, thank you. I put too many zeros in there. Dang damn it. Erase. Can I erase this? No, erases everything. So we're in the table, inside the table, 0.0, yes, there we go, 0.25. So 0.25, oh, there it's actually in the table. So if I put in 0.25, My answer is
Can you tell me how you find that?
I can. So,
Negative
I'm
1.96.
So I'm going to switch shares for a minute. So the whiteboard will come back in 1 second. I'm going to erase it this time. I'm on my computer. It's my iPad. I knew I was going to play. So here's a picture of a Z table, right? This one's all on one page. So I have to find the value 0.025. So here's 0.020. Here's 0.026. 256. Ah, there it is right there. Let me turn on my little coloring thing. Change my color to red.
Yeah, I could see it. 0.250.
So we're right there. So we'll come over here and find the negative 1.9, and then we go up and we find 0.06. So we put those two numbers together and we get negative 1.96.
Okay. All right, got it.
So go back. Oh, let me get rid of my drawings. Share whiteboard again. So go back to our board. So z-score of negative 1.96, right? And then I come over here to find my positive. So this is 0.25% to the right. But how can I get numbers to the right in the table?
No.
No. So for this one, I have to go to the table. So inside the table. Inside the table, find 0.975. And how did I get that? I took 100% minus 25%. I mean, not 25%, sorry, 2.5%. And I get 97.5%. So now I have to go find 0.975 in the table. And I get a z-score of
1.96.
1.96. Why are the two numbers the same? The signs are different, but why are the two
It's
numbers the same?
symmetrical.
Because it's symmetrical. That's the good news with confidence intervals. Once you find one z-score, you already know the other. Just one's positive and one's negative. Always. That's always going to happen. So what we call this in confidence intervals, these are called, I'm trying to bring up my text box so I don't have to try to write it out. These are called my critical values. Sorry, I can't spell. Most of you already know. These are my critical values for a confidence interval. All right, and that probably in confidence intervals is the hardest thing to do, is what we just did. So if you feel comfortable with that, hopefully you're smiling right now, because that is the hardest part of confidence intervals. The hardest part of confidence intervals is finding the critical value. All right. Now, on your charts, if you look on the positive z-score side and you look in the bottom right-hand corner, there is a little table. And that little table says common critical values. And you can see if I have a 95% confidence level, my critical value is 1.96. If I have a 90% confidence level, my critical value is 1.645. And if I have a 99% confidence interval, my critical value is 2.575. And this goes back to the rule of thumb, right? According to the rule of thumb, 95% of my data is within two standard deviations, right? Well, that's an estimate. Now we are finding the precise number. The precise standard deviation in a 95% confidence interval is not the number 2, it's the number 1.96, which most people round to 2. Right? So that's where that came from before we could do statistics. Now, you can actually find the exact spot. And because the reason this little table's here is because these are common confidence intervals, right? Most of the time when we apply confidence intervals in the real world, everything is either, a lot of times people use 90, 95, and 99. And that'll make a lot more sense when we get into chapter 8. But those are the common ones. But because they're the common ones, probably on the test, I will not use those confidence intervals. I will make you come up with different ones to make sure that you can find your own critical value besides just taking one off the chart. So let's do one more of these before we put all of this together. And I don't want to erase this so in case I want to come back to it. So I'm going to go to a new page. And final class of a let's say an 80%, 87% confidence interval. So I know 87% is in the middle. Draw my 2 lines down. I know because it's a standard normal that I am still centered at 0. And I got to find my negative z. That's supposed to be a z, not a 2. And my positive z. So 87% confidence interval. I'm just going to call it CI. What do I have to do first?
I have a quick question.
What's up, Doug?
So if, say, I already have the number for the confidence interval, can I just divide that by 2 and to get?
Not the number, not the confidence.
No.
You can't divide the confidence.
That minus 100% and then just divide it 2.
Perfect. So if I do 100%
divided by
minus
82.
87%,
7, yeah.
that gives me 13%, right?
Mm-hmm.
And then if I divide that 2, I get 6.5%. Which means this is we'll keep it like we are, 6.5%. This tail is 6.5. Can't write 5s very good with a mouse. 6.5%. So now I go to my table.
What happens if you can't find on the table exactly 0.065?
And you find the closest you can.
Okay.
So let's see, what do we get here? 0.65.
Negative 1.5.
Negative 1.5.
Negative 1.51.
Okay, yep, I see it now. So table to this becomes,
If we find the closest thing, it's fine, right?
so this becomes what you said, negative 1.51. Okay, yep. Which means this number has to be
1.51.
1.51.
Cool.
Now, to answer your question about which number I should pick. So if I go to 1.51, I get 0.655, right? Which means I'm a little bit bigger than 6.5%, which means I'm actually coming in a little bit into this region, right?
Mm-hmm.
Right? I'm going a little bit into this region, which means I'm not actually finding an 87% confidence interval. I'm finding something a little bit less, which is not wrong, right? It's okay. But there is some that argue that they'd rather not take away and they'd rather be a little more cautious. So they'd rather go a little to this side instead of cutting out of my 87%. I want to go a little more than 87%. right? Which means I'd have to pick out something a little less than 6.5.
Should be the negative 1.5, which I don't know the
Right.
meaning
So
of
then
this
I
one.
might put negative 1.52 and a positive 1.52. In my opinion, that's just a matter of preference. The book will take, I mean, Pearson and I will take either answer. It really comes down to what you as a person feels, right? If you want to make sure that you cover all 87%, then maybe you go a little bit to the left. Maybe you're a person that like, I want to get the number that's the closest to 6.5, and 6.55 is closer than 6.43. So maybe that's your argument for picking 1.51, right? It is really a matter of preference. And this is why, from my people that are going to use technology, you're going to get a different answer, because technology finds the precise answer, which is somewhere between 1.51 and 1.52. It'll probably be 1.53 maybe. I'm not 1.513. You know, it'll just add a number. It'll go to the thousandths place to get to that precise 87%. So long answer to your question, but it is the right answer to your question. Either one of the numbers are going to be fine. And it's not going to really make a difference in your full answer in the end, because you're only off in the hundredths place by 1. Does that make sense? So that is our answers to our critical values. So like I said, this is the most challenging part of a confidence interval. Now that we found the critical values, let's talk about what a confidence interval is. A confidence interval is not how accurate you are. A confidence interval is not how accurate your calculations are. A confidence interval is not a probability, right? A confidence interval is how confident you are in your results. All right. So if I don't want to do that. Oh, there it goes. Just the delay in my computer. If I draw a bell curve, right, and I am centered at the mean. So we're not centered at 0 no more. We're centered at the mean, right? And I don't know what the mean is, which is typically really what happens in real life, right? We've talked about this before. We don't know what the true mean height of humans are, right? So we don't know what the true mean is, but we can estimate it by creating a confidence interval, right? And say we do our 90, oops, on the wrong thing again. Say we do a 95% confidence interval. Right? I can get my lower limit of some height. And some upper limit of some height. And then I can say, I'll write it on text so you can see it. And we're going to do one with numbers here in a second. I am 95% confident that the true average adult height of humans lies within the interval. Then we have to put some number, right? That is the proper way of interpreting a confidence interval. And because the reason it's not how accurate you are, if I had all of you go poll 50 people, 50 adults, and then I have you build a confidence interval of those 50 adults, and next class you come back and you are all present your results, every single one of you will have a different confidence interval. No one's confidence interval will be the same. And I will assume that you did your calculations correct. So therefore, every single one of you have created the right confidence interval. So that's what makes confidence intervals tricky. They're based off your sample. And since no one knows what the true average is, then no one can really tell you you're wrong, right? And so confidence intervals are based off your sample statistics. And that typically when we do these in the real world is when you're doing some kind of analysis, which so you did in your projects, and you don't know what the true answer is that you're doing it in, so you've taken a sample of data to do some analysis, you can use your confidence interval to say, this is how confident I am that this true value lies within this interval. So we had a student in the class, I'm gonna get her permission first, so I don't want to talk about it, who her project was on how long a mom breastfeeds. So we don't know the true amount of time that any mother that breastfeeds does, but we have a range of time intervals that people do. So that student can take their data and now calculate a confidence interval and say, I am 95% confident that a mom that breastfeeds their child from 9 months to 15. I just made up two numbers because I don't know what they would be. But based on the results of that project, the student will be able to give an interval now that they can share with people that she's doing the research for. Right? That's the point of confidence intervals. And this is kind of how the coronavirus is going right now, right? They're trying to flatten the bell curve, and they're trying to figure out how long social isolation should last, right? So that finding this interval where once we reach this threshold, that maybe we can lift some of the restrictions. So that's how this is applied kind of in the real world. The key to confidence intervals, though, it is not how accurate you are. It is not a probability. And if everyone calculates a confidence interval off a different data set, a different sample data set, even if it came from the same population, say human heights, everyone's confidence interval will probably be different. All right, it'll be close. All the confidence intervals hopefully are close in values, but they won't be the exact. Any questions on kind of what confidence intervals are used for? All right, I don't see anything in chat, so let's go to a new table here. Now, here's where it comes down to the fun formulas and the fun symbols. So if everyone takes their pullout and goes to chapter 7, and everybody takes their pullout and goes to chapter 7, you can see we have what, 1, 2, 3 different formulas, right? We have a formula for proportion problems, actually 2 formulas for the mean problem, and we have a formula for the variance. So today I am just going to worry about the proportion problem, and next class we will do the mean and the variance.
Are you looking at chapter 8?
Nope, chapter 7. Just the confidence interval formulas, not the sample size.
My chapter 7 is the sample size, determinants, proportion, and mean.
On your pullout?
Yeah.
Confidence interval, one population, chapter 7.
There's a section above.
Oh, okay. Thank you. I was like, sorry. You're right.
Okay. Yeah. With confidence interval section right now. Yeah, we have a sample size, which we'll talk about as well. But no, just the confidence intervals. So to know which confidence interval you pick, it's what type of problem you're doing. If I'm doing a proportion problem, which means I am finding this many of this many, right? Which is back to the student who's got the breastfeeding project, right? That was a proportion project. Well, it could be mean. I think that They did actually the average amount of months. So that one can go either way depending on how you write it. But that's where you have to be clear what you're trying to answer. Are you trying to look at the proportion amount of people that do something, or the mean of something that they do? And typically in the problem for calculating these, that's why it's not bad, it has the words. It will say, build a confidence interval of the proportion. Build a confidence interval of the mean. Build the confidence interval of the variance or standard deviation, right? So let's kind of talk about these formulas, and I'm going to try my best to write freehand on here the first formula. So my first confidence interval formula, let me move this guy out of my way. Let's put it in black so I know everybody can see it easily enough, is p hat minus e, which is less than p, which is less than p hat, plus e, right? And save some space. I can't, now my fingers are where E is my margin of error, right? And it has its own formula where E equals Z alpha over 2 square root of p hat, that's up to q, but q hat over n. So very, very ugly formula, right? Well, let's talk about these things. Do I get some cool arrows? I do. Let's change some colors here. What is P? This is where I said no in our symbols.
Population.
Population.
Population proportion. Perfect. This we do not know. We will never know. Ever, ever, ever know. So that in our formula stays P. Okay? Because the only way we can know the population proportion of something is if we ask everybody inside the population. If we cannot ask everybody inside the entire population, we can't find the population proportion. Because if we could, then we wouldn't need to do a comp. I could talk to every single person and get my answer to my question, then I don't have to build a confidence interval of what I think the population proportion. But that's really hard to do, because even think about it. If I wanted to take one class and ask everybody's opinion on something to do a proportion problem, I think maybe one out of all of our semesters, even before coronavirus happened, that everybody was in class at the same time. So every time we did anything in class, it was still just a sample, even based on our class, because we couldn't even get 27 of us to all come to class at the same time. So if we can't do 27 people, I'm pretty sure we can't do a couple million people, right? So this is why you'll never know what the true proportion is. So if we can't find the population proportion, what is the next best thing to find? What is p hat?
Sample proportion.
The sample proportion. And that we can find, right? And that's what you did for your project. You went out and you found a sample. So we can find a sample proportion. So we know what p hat is. P hat is our sample proportion. So what is q hat?
That doesn't look like a Q at all, by the way.
I know. I'll try to fix my cue. Let's go back to black. I can draw a cue with a mouse.
Sample proportion equal to 1 minus p hat. So
So the
1 minus the sample proportion?
That's it. So there's where we find Q hat. Q hat is just 1 minus P hat. That's the sample proportion. Basically, it's, remember the sample proportion, P hat is the people that we consider success. Q hat is the people we consider failure, depending on what the question is, right? Failure doesn't mean bad. You could be asking a question, do you think you should wear a mask during the coronavirus if you leave your house, right? P hat will be the people that say yes. Q hat would be the people that say no,
No.
right? So Q hat doesn't mean such a failure. It just means it's opposite of whatever you classify the success to be, right? And then what is N?
Number of trials.
N is always our
Number of trials.
number of trials or our sample size, right? So all of the, so far we've seen this new formula, but we have used everything in this new formula except for one thing, right? The one new thing in the formula. Oops, my arrow went the wrong way. Let's erase. That's the new guy in the formula. So as you look at this ugly formula, hopefully that's easier attention a little bit, that this is that one symbol. And all that symbol is that's your critical value. That's why we solved that first. That was the new thing of today. Because if you draw a normal distribution, P is going to go right in the center. And then I come up with my confidence interval. And this time I am going to do, just to be different, a 90% confidence interval. Because, oh, I haven't gone to that yet, but we will in a second here. It's saying, based on this formula, that if I'm doing a proportion problem, my letter is Z, which tells me I'm using what table?
Z chart.
Using the Z chart. So if I'm using the Z chart, then I just go to my little thing in the bottom where it says common critical values. And my critical value for a 90% confidence interval will be, where's my text box? A negative 1.645. And a positive 1.645. Good question. So why does it have an alpha over 2, right? If I'm doing a confidence interval, how many tails do I have?
2.
So just like we did before. So to find the tails, right, because I just jumped to the answer because we've done this before. If I'm doing a 90% confidence interval, text box, where you at? So 90% confidence interval. Then to find the area in the tails, so tails, line up my fingers here, people, tails, that is 100% minus the 90%, which equals 10%. Well, I have how many tails? 2. So like Dex said earlier, I take 10%, I divide it by 2, and I get 5%, which means there's 5% in this tail, and there is 5% in this tail. So that's where this 2 comes from. I'm dividing, that 2 means to do that. So the only symbol we haven't talked about is this crazy looking alpha. And all alpha is, alpha, let me text box it. Because that little symbol, I'll draw it here in a minute.
Yeah, I was going to say, can you make the symbol a little easier to see?
Yeah, I will. Alpha
Thank you.
is the area in the tails, or the percentage in the tails, or the probability of being in the tails, right? And if I draw my symbol a little slower, and I'll pick an easier color to see than probably red, alpha
Oh, it's the fish.
it's the fish. So alpha is the area in the tails. I have 2 tails, so therefore I divide it by 2, and that's why we have the symbol here, alpha over 2. Because I'm taking the area in the tails, I'm dividing it by 2 because I have 2 of them, and then the z value tells me which chart to use. Kind of making a little sense of where all these things come from. We haven't still even calculated a full problem yet.
Okay, so that's not actually an A, it's an alpha symbol
Yeah.
next to the Z.
Yes.
Okay.
Yeah. You know, on your charts, it's hard to see. It looks like an A. If you want to make it an A, I don't care for A for alpha. They use a Greek, but if you want to make it an A, as long as you just know, my big thing that I want you to know about that is the area that you are in the tails, which is considered the bad area. It's outside of our confidence interval, right? So that's why it's outside of our interval. We don't want to be on the outside of our interval. Now, just for a sec, and we're not going to get to this today, but just so you can kind of see how the formulas are different. If you go to the mean formula, it just says x bar minus e is less than mu, which is greater than x bar plus e, right? So the only difference in the confidence interval formulas for those is the e's. And notice on the mean, there's 2 different e formulas, which we'll get way more detail next class, but they're basically the same, except for one has a z and one has a t. Well, the z means I use the z table. The t means I use the t table, which we haven't used yet. We'll do that next class. And that is the only difference is you're going to use a different table. We're going to learn how to use a different table next class. So knowing your symbols will help a lot knowing how to solve each formula. Because once you pick the right formula, as long as you put the correct numbers in the right place and you don't mess up your arithmetic, you get the correct answer. So let's do a problem from start to finish. And now I'm on my computer, I can actually type. So I polled 100 people. Yeah, we'll do 100 people. 100 people about I polled 100 students at CMCC to if they plan to take what are we calling this thing? Distance learning? Or just take summer classes. Campus is still closed. So there we go. I pulled 100 students at CMCC to see if they plan to take classes if the campus is closed. So in my sample, we'll say 60% said they will not take classes if the campus is closed. right? So now the campus has asked me to just tell them, build a confidence interval. So construct a confidence interval of the proportion of students who will not take summer classes if campus is closed. Let's see, we are going to do, I'll put up here, construct a 88% confidence interval. No, we already, yeah, that's fine. We'll leave it at that. There we go. So there's our problem that we're solving for the school, right? So just like we did in chapter 6, first thing I would recommend you do is draw a picture. We draw our picture. Ooh, wow, that was a horrible normal distribution. And we know the true proportion of CMC students goes in the middle. I am building a 88% confidence interval. So my alpha equals 12%. I got that from doing 100 minus 88. So therefore my alpha over 2 is 6%. So I have 6% in this tail. I have 6% in this tail. So now I just use my formula. So I need my p hat minus my e is less than equal to p is less than equal to p hat plus, that's a horrible plus sign, plus e. Kind of getting worse as I go. Where e equals z, that's a z, z alpha over 2 square root p hat q hat n. Phew. That hurt. Good news, now I don't have to make all these funky symbols. I can actually type. So first thing we want to find is e. So let's actually do that text first. So e equals, well, I got to find my z alpha over 2, right? So how do I find that? And that is the value that goes right there. I might have to erase my thing for a minute. I'll put it back in a second. Anyone got it? Anyone got a z for me?
Negative 1.55.
All right, so that's on the other side. So that means this is 1.55.
Yep.
And this guy over here is, come on, text box, negative 1.55. Okay, is everyone agreeing with Tammy?
Yep.
Okay, I'm good with that. So, note we only want one of them. It's always positive. And the reason we always pick the positive is because, change my color, that's where the plus minus comes from. There is my positive 1.55. There is my negative 1.55. So we only need one of them from the E formula because we're going to take both into account when we put E back in here. So when I find the positive E, that is for putting in a positive 1.55. When I find my negative E, that's when I put in a negative 1.55. But it doesn't change what E is. It just makes positive and negative. So instead of doing the calculations twice, we only have to do them once by doing it this way. So I do 1.55. And then I'm going to just put a space here. Then I'll put the square root symbol in. What is my hat?
This 60?
Yeah, 60%, right? Because in this case, we're calling a success the people who do not want to take summer classes. So that's a 0.6. I'm going to multiply that by Q hat, which is a 0.
The
0.4?
sample proportion, so 100? No, 4.
So P hat is, Q hat is the complement of P hat. So if I take
Okay,
1,
so-
that's why it's 1 minus P hat.
That's right.
P
Okay.
hat plus Q hat have to equal 100%.
Okay.
And then my N is 100 students. So now I'll free draw the rest of the formula in here. Take the square root of all this mess under here, and I am dividing by this. So if I type that into my calculator, I get 1.55 times the square root, 0.6 times 0.4 divided by 100. So my E, put it in the text box, my E, not little e, E equals 0.0759. Does anyone agree with my calculations? Make sure I typed them in right?
Yeah, I got that.
Okay, good. So there's my E. So now if I come back to my confidence interval formula, I take P hat, which is 0.6, minus 0.0759. Maybe some room here because I'm going to put some symbols in. Oh, I can put them, type them in. It's just a P. So it's less than P, less than 0.6 plus 0.0759. So this is going to be plus 0.6. This first number, I get 0.676. Lower bound, 0.6 minus 0.07. 0.524. And there is my confidence interval answer. I don't worry. A little bit bigger. So if I write out per way now, I am 88% at the proportion of CMCC students who will not take summer classes. I know it's off the screen. I'll fix that. summer classes is between 52.4% and 67.6%. So there is a complete problem. Lots of steps, right? And again, in my opinion, finding the critical value is the hardest, because that's the only part you actually had to do work. The rest of it, you just had to put the numbers in the correct place. Now, if you don't know your symbols, then put numbers in the correct place can be challenging. But if you know your symbols, new thing you have to find today is the critical value, right? So that's where you put all the numbers in where they go. And as long as you're careful with your calculations, everything should go all right.
Can you
And
lift up
I'm
and
not
show
saying
us
Is
what
it normal if we get an extra?
Go ahead, Mike.
Is it normal if we got an extra 0? Because I got 0.00759.
Was my answer wrong? Check your calculations. Make sure you have all your decimals in the right place, because I got 0.0759. That's 1.55 times the square root of 0.6 times 0.4. Make sure you didn't put 0.04 or something. Divided by 100. So you either, when you type in your calculator,
That's what I put.
you have a decimal throw in there. Make sure that your 0.6, 0.4, and 100 are all under your square root as well. But it sounds like it is, because you got the right number. It's just, I think you either typed a decimal in somewhere wrong. Put an extra 0 somewhere. Unfortunately, now I can't look at people's calculators like I could in class to figure out what you did wrong. Tammy, what was your question?
I don't even remember. I got distracted. Sorry. The kids are screaming at each other downstairs.
Yeah.
I remember. Can you just, I can't see how you wrote the rest of your sentence. I don't know if you can flip that up a little bit, the answer.
That helped. I drug it up a little. I don't know if that helped or not.
No. Did you just write like the point is between 0.524 and
Tammy, you
And-
can move the pictures to a different spot on the screen if you're on a computer.
me? I'm on a laptop.
Yeah, so you should be able to move people's pictures to different spots.
No, it's my little, it's the, like where my mute button is and where I see that that is covering it. And I
But
can't
you
figure out how
can
to
move
make
that box too.
You
Yeah.
can? Okay.
Click on that box and you can move it. I move mine all the time.
I move everything all the time.
Yes,
Okay.
I know, me too. It's annoying. When you hear me stop talking, it's I'm moving something so I can see as well. I wish we could close some of these things out and just not have them and figure out how to do that yet.
There we go. Got it. Thank you.
Don't mind my baby screaming in the background. She's chasing the dog with a pretend grocery cart.
Right. Mine is downstairs with the babysitter refusing to put clothes on.
Oh, well, mine has clothes on for now. And then the other one's doing learning with me.
Did you get that one to recalculate, Mike, okay? Or
No, I'm still getting the same answer.
God, I wish I could see what you're
I'm
doing.
also getting the same answer as Michael. I just redid it myself.
Okay, well, my
And everybody
answer
else?
is yours.
Okay. You
So
guys
I
put
could have
steps
done
or
something wrong.
It's like I got the same numbers. It's just I have an extra 0, and I don't know why.
Yeah,
But
I put
I'm saying
in
you're typing it all in
parentheses.
once in your calculator, or are you doing it in steps like in equals, equals, equals?
All in once.
all in once. I put parentheses around the 0.6 times 0.4.
Yeah, me too.
That's what you're doing wrong.
Oh, okay.
All you have to do is 0.6, make sure you have a radical line, 0.6 times 0.4 divided by 100, because your radical sign automatically puts a percent parenthesis in. And so when you close that one, it stops taking the square root.
So how do we get it out?
Just, you said you typed it in, just don't type it in. You're probably going to
Well, I
start over
clicked-
for the TI-30. You're on a TI-30X. I don't have my TI-30Xs. I think someone took mine. So I have a Casio now. So my Casio doesn't put a parenthesis in. Let's see if my Texas does here on my TI-84. 1.55 times the square root. Well, this one doesn't put a parenthesis in either. I'm doing it on a different calculator just to see if it changes. Oops, not hit divide. Divided by 100. No, I got the same answer on that calculator too. You can
I
try
guess now,
sharing.
like,
Go ahead.
I guess now, like, whenever I get the answer, I'm just going to take away that extra 0 then.
No, because it's not always going to be. It's the only reason you have an extra 0 because it's a 100. If it's not a 100, it's going to change all the numbers.
Oh, okay.
Can you share your
So
screen
only
and
when it's
hold your
100.
calculator up to your camera? Here, I'll stop sharing mine. Everybody have this, 'cause as soon as I stop sharing this, this is going away. No, it won't. Because I'm on my computer, I don't think. Well, too late now.
6.
So, Mike, hold it up to your camera so I can see it. And then
Oh, no, I'm
maybe
going
I
to
can-
type it in again.
Okay.
I don't
No,
know
I
how
want- I
to
want
share your
speaker.
camera on this.
Okay, hold on. 1.55. Oh, yeah. Oh, I got to stop talking. Go ahead. Talk, Mike, so you get
Yeah.
big picture.
1.55 square root. Then it immediately puts into parentheses 0.6 times 0.4. Then you divide it by 100, and I clicked equals, and then it brought me up to the
Okay, don't click equals.
0.00.
Put it back up. And then talk again. Yeah, don't do the equals.
Okay.
So I can see what's at the end. All right, say something so you take over big screen again.
0.6 times 0.4, close
Here
the
it is.
parentheses,
You have a parentheses
divided by
after
100.
you have a parentheses after your 0.4 in your calculator still. Look at your calculator. You have a
Because
parentheses
it won't.
after.
Yeah, because it would automatically put a parentheses in it right when I click square root.
It puts 2 in there? I thought it only put 1.
It puts 1, but I closed it.
Don't close it to after the 100. You're closing it after the 0.4. Don't close it to after the 100.
Okay. Now I got it.
Oh, we actually.
All right.
I was hoping we get through 2
Thank
today.
you.
So what I'll probably do next class. Yeah, you're welcome. What I'll probably do next class is we'll start off with another. Actually, we'll go right with the mean one because it's very similar. We'll do a mean. We'll do both mean ones. So we'll do another Z with the mean, and then we'll learn how to do the T, and then probably a standard deviation. So my goal next class is to get through 3 different kind of close notes for us. Any questions on what we covered today? The key today: know your symbols. Know how to read the chart, which I think most of you get comfortable with because we've been doing that for a while, and make sure you do a couple of these in practice so you can know how to properly put them into your calculator. Excel will not, there is a special code in Excel to do all of this at once. You have to, even in Excel, do these things. The only thing Excel does is it can find the critical value for you quickly, so you don't have to use the table. But that's the same way that you're doing it in Chapter 6. You would still have to create these formulas in Excel if you're going to use technology. The only technology out there that you have access to maybe to do all this at once is if you have a TI-84 calculator. And I can talk about that with students at the end of next class who have one of these, how to use it. Or if you've been on Pearson and you've been practicing using the software on there called StatCrunch will do the whole process for you as well. I wouldn't try to learn all those right now unless you're tech savvy. So the best thing is to make sure that you know how to read these formulas, know the symbols, and know how to put them into a calculator. The next 5 minutes. Okay. All right, so I'll post this recording today. Remember, we have some shorter versions as well if you don't want to watch the whole hour plus however long we're going today. Next class or next week, we'll do the other 3 formulas. So have a good weekend. I've been posting the videos. I think seen some of you have been watching them, so that's good. They're there if you need them. If you don't, they're not. You don't need to watch them either, but they're there if you want them. I'll stay on for the next few minutes for anybody who has any questions about anything.
So I got a quick question. When